Okay, so again, we are expanding with these special functions. So we are looking at exponential functions, their differentiation. So one of the key aspects is we have to know which one actually gives us access into exponential differentiation. So the first is we have to know this primary one, right? So this gives us what? This gives us a repeat of this. So again, if we went back to the first principles, we would find that this is actually true, right? And so having had seen that, what other ones are important, the other ones which are important for us to know. We don't have to derive these at this point. We just have to know them. Out of interest, you can do them when time allows. Okay. So here, what is going to be the solution? You have to recognize that this here is our function, right? So how many functions do we have? This is a constant, and that is the variable. Okay, so notice where the variable is. The variable is actually here, right? So what we have in this case is we're not going to repeat this the way it was, but we're going to say that we're going to have ax, okay? This function, yes, that's repeated like that, but we're not going to forget about this constant here. Remember here we didn't have, because we're looking at natural logs, okay? So here now, this is not a natural, this is not e, right? So that's why we're not going to repeat it here. Then here we're going to have ln a. Okay, here, if you want, you can put ln, natural log of e, which is 1. So here we're going to have 1. If we have 1 here, then it falls away and we remain with this. But in this case here, we still have this one. So here we can bring this back if we want, like that. So this is 1, and that's why we have ex. Now, this one, yes, repeats, but then this does not fall away, right? Okay, so that's our second one. The first is that one. Okay, so let's separate them. The second is this one. Okay, what is the third variation of this same one? Now, remember, we can add the function now. So this is the second variation, the third variation actually. So now we're going to have, what if we have e? Okay, and I think you know the variations that we're going to go to. So now we're just adding a function. Okay, we're saying that this function is actually fx. That's why we are going with gx. What is the meaning of this? Now remember, things have changed now. Okay, things have changed. What has changed? We now have a function here. So this is actually nested. So this is almost like your chain rules. Okay, so we're going to find the differential of this one, which is going to be gx, like that. If it was u, we'd say du over dx, right? What else can we do here? Well, we find the differential of this one. It will be like u now, e power u. What will that be? It will just repeat itself, isn't it? So it will be gx, like that. Okay, so that will be the differential of this one. So that's the second variation, the third variation. Okay, so now we can look at the fourth variation. Okay, and I'm sure we know where we're going with this, isn't it? The story is actually simple. So now we're going to have a different constant there, and then we have gx here. Now we have to be careful here. This has changed, right? It's not e. So meaning that this has to be returned. It's not going to become 1. This has to be used. And then this is also a bigger function. So we have 3 things that we have to consider here. So how are we going to consider them? Let's begin. The first is, like I said, you have to really know what aspects of, you have to know what parts do you have in an expression, right? If you know the parts that you have, then you're able to simplify each. okay, or you're able to manipulate each. Otherwise, if you don't know the parts, you will not be attending to everything that needs to be attended to. So you have to look and recognize what you need to actually look at. So here now, what are we looking at? So here we start with this function that is going to give us first the differential of that function. So we've attended to that part. Then the next function that we're going to differentiate is the overall function. So the overall function will become a g x, right? There's one part that's left. What's going to happen to the a? So we recognize the parts. We said that we've got this part, we've got the overall part, and then we've got this a here. So that one we said is going to be an a, right? So this is the third variation, the fourth variation rather. So we have 1, we have 2, we have 3, and then we have 4, right? Similar to logarithms. If we know what went on here, then we're able to manipulate complex differential equations. Okay, so now that we've done the difference, we've done the introduction, we've done the introduction in 3 parts. The first was just the logarithms and operations. The second was differentiation of logarithms. Then the third is this differentiation of exponential functions. Now we can go on and try a number of questions. Okay.